Hi guys, welcome to this quick recording concerning a question on homework 4. One of you guys asked a question and I thought that you guys should be aware of this because I thought I should share that with you guys. So let me share the screen. It's basically about the first two problems from the homework set, okay? In the homework set, you were given the mass of all of the carbon dioxide in the atmosphere of Venus being 4.6 times 10 to the power 20 kilograms. You were also given the atomic mass of carbon being 12, the atomic mass of oxygen being 16, and the atomic mass of the hydrogen being 1. And basically, the idea is to extract all of the oxygen from the carbon dioxide and make water out of it. So how much water we're going to get? Well, if you think in terms of the proportions, for all of this mass of oxygen inside the carbon dioxide molecule, I have 2 atoms for each carbon atom. And each molecule weighs 44 basically atomic masses. Because I have 2 times 32, that's 2 times 16, that's 32, plus 12, that's 44 atomic masses for the entire molecule. 32 of which are coming from the oxygen itself. So the entire mass of 4.6 times 10 to the power 20 kilograms, 32 of which out of 44 is actually oxygen. So this is how much oxygen we're going to end up with if we do that operation. So that's how much oxygen we're going to end up with. 32 over 42 out of 44 times this much number, which is the mass of the current carbon dioxide in the atmosphere. Okay. If we were to form a water molecule in this case is made up of an oxygen and 2 hydrogen atoms. So the 2 hydrogen atoms are 1 times 2, which is 2 plus 16, that's 18. So the mass of a water molecule in this case is a lot lighter than carbon dioxide. And it's only 18 grams per mole, or 18 atomic masses per basically molecule. 16 of which are the oxygen. So if we bring this much oxygen from the carbon dioxide, they will amount to 16 out of 18 of the entire mass of the water that we can form. So how much water we can form, all we have to do is divide by this number, both sides of the equation, and we end up with a mass of the water being 18 over 16 times 32 over 44 times this number, the mass of the current carbon dioxide in the atmosphere of Venus. So this is how much water we're going to end up with. If we plug in the numbers in the calculator, this is how much mass of oxygen water we're going to end up with, potentially on the planet Venus. If we do this operation, if we somehow extract all of the carbon dioxide from the atmosphere and convert it into water, we end up with this number. The second part, it says compare the two between that of the Earth and that of Venus. And that's all we have to do is just take the ratio. Obviously, the Earth, even right now, still has more water in it than Venus, converting all of its carbon dioxide into water. And it's almost 4 times, 3.72. So if we do the ratio of these two numbers. This next problem asks you to see how thin the layer of the of this water is. What's the thickness of the water if it were to cover the entire planet? And this is not a far-fetched assumption because, as you saw from the same unit 41, is that the planet has hardly any mountains. So it's not out of the realm of possibility that the planet will be basically a watery world, with the exception of probably the tips of the mountains that are going to be in dry lands. Anyway, the point being in here is we need to take all of that water and spread it out through the entire surface. And this formula, you need it. The surface area of a sphere is 4 pi times the radius squared. And the radius of Venus is 6,051 kilometers. You need to convert it to meters. So you need to multiply it by 1,000. So the surface area should be 4 times pi times 6.051 times 10 to the power 6, the whole thing squared. Remember, r squared, okay? So this is the area. So if I were to spread it throughout the entire surface, it will occupy a depth of h, or a height of h for the water above the surface. So the volume in this case is going to be the surface area times the height. So whatever that surface area is times the height. There is another way for me to finding the volume using the density formula. It says the density is mass over volume, and the density also was given to you to be 1,000 kilograms per cubic meter. Since I do convert it here into meters, So this formula works fine for me because everything is in the standard units. Kilogram cancels the kilogram. I have a meter cube, but the area will bring me another meter squared, so I'll be left with a meter. So the height is going to be in meters. So this is the volume on one side, which is surface times height. And in here, it shows the volume, which is mass divided by density. So I have both numbers now in this case, which I plug them into the formula. And if you do the numbers, it should be a little over 800 meters. So it's not going to be even a kilometer deep. And the Earth has oceans that are actually several kilometers deep. So this is a conversion. This is why we say that the atmosphere, the oceans of Venus were actually thin oceans, and they evaporated, and now the surface does not have any water. Thank you. Let me stop the recording.